This episode is sponsored by Wix Studio.
When is the last time you listened to a podcast about web development, web design, and small business and didn't fall asleep? Yes, we cover web development, web design, and small business, but like actual human beings with personalities. If you're a beginner, we're not going to talk over your head. It's more like asking your buddy for help. We have guests, we have fun, and let me tell you, these two can get off on a tangent. Ladies and gentlemen, welcome to HTML All the Things Podcast. This is Matt Lawrence and Mike Curran.
That's it, everybody. We are back, and this is the HTML All the Things Podcast. This episode is going to be all about code quality. In fact, we titled it, Why Code Quality Matters, Testing, Linting, Refactoring. Now, funny enough, we were playing with a whole bunch of different we were brainstorming titles, trying to figure it out. And we were like, man, should we try to take a elitist angle on this one? Should we try to do something like your code quality is keeping you from a job, or can't get a job and improve your code quality, or your code quality is holding you back? But then I realized, hang on, I'm kind of in a hybrid role where I half use no code, half use code, half do server stuff. So I'm in a weird spot where it'd be if I scream that out and be like, yo, improve your code and get a job, and then you look at some of my code, you'll be like, Matt's code sucks. And then I'll feel bad. But anyway, so we landed on the title we landed on because it's neutral. But the reason why I even mention these elitist titles is because I'm curious if you guys think we should kind of take a stance on some stuff sometimes. Should we be like, yo, do this to get a job, or do this to make, this code faster, or whatever the certain context is, and try to take not even necessarily elitist, but a more a hard approach, rather than saying well, you're not doing too good, but you're doing okay. Be like, nah, you're doing bad. That sucks. Is that, I don't know. I'm on the fence. But anyway, if this sounds interesting to you and you want to support the show, you can go and check us out on that Patreon. Leave a review or rating on your podcast app. Join us in our Discord server, or share this with your friends. Now, Mike, you're actually the writer of this episode. We're going to be talking about code quality, of course. And the thing I'm interested the most in, so maybe we'll dive into when we get there, is actually testing. Because as a person that, just writes little things to usually manipulate UI, I don't do tests at all. And I have done tests before, but I've actually done that with either hardware hybrids, or writing tests for just hardware. So we'll see what's up. So Mike, please, sir, tell us why code quality matters.
Yeah, absolutely. So I think this comes down to a couple of different things, and something that Matt, you just mentioned, should we take a stance on stuff? This is part of it a little bit, because if you're just kind of loosey-goosey, if you're a team lead and you're not taking stances on things, and you're just letting everything kind of go in terms of code reviews, you're it's fine, everything's going to work, as long as it works and it builds, I don't really care. That affects stuff in the long term quite a bit. And I've done that before. Again, I think I mentioned it quite a few times on different episodes, but one of my weaknesses as a team lead, or as someone that's led a few teams, is that I'm not very good at giving the critical feedback, and I'm not very good at maintaining that code quality because of it. So that's something that I've taken a little bit more responsibility on and trying to go with. And that's, again, going back to being blunt, is that sometimes you just got to be blunt and be like, hey, if we're all okay with this kind of structure that we've set out for ourselves, or we chose this structure a while ago, even if you weren't part of that decision, we have to kind of stick to it. Whether we can change it or not, that's a totally different question, because we can have the conversations of hey, if we really want to use vars and we're not allowing people to use vars, let's have that conversation. You know what I mean? That's perfectly fine. There's could be situations where you need to use it, but there's certain decisions that were made, and let's at least stick to those decisions as we're going forward. And that's kind of the conversations that I have to have with some people as I'm trying to maintain code quality. And what I've noticed a lot in new developers, or in developers coming onto teams for the first time and that have worked only by themselves or with very small teams, is that this very much gets put on the side burner. And for them, it's all about I got to do this quickly. I got to get all these features done. I got to build. And the reality is that can actually hurt a team more than help a team, because most developers on it, when you come into a new developer team, you have to assume that most developers can program and can quickly build features. They've been there for a while. You have to assume that. I mean, sometimes it's not true. Sometimes you have some, a lame duck or someone that like just isn't able to code very well. Like that can happen. But the reality is, like, most of the time, everyone on the team can code. That's a given. And the problem comes in is that when everyone on the team can code, well, what separates you? Well, what separates you is the code quality. Like, how well can you conform to the standards that were set for that project? How well can you write code that not only works but doesn't break and is easy to maintain? How well can you document your code? Like, how well can your code be read, right? Like, what's the readability of your code? So that's the stuff that's going to separate you more than you being able to write a quick feature and submit a PR. So that's what I want to get across in this episode is that, yes, you've learned how to program. That's great. That's a huge step. I'm not trying to diminish that. That's not easy in any way, shape, or form. That's hard to get to. But when you do get there, that's not where you stop. That's where you start to look at, okay, how do I make my code better? And that's really the crux of code quality, right? So what does it mean to write better code? Well, the code has to be tested, well tested. It has to be formatted the right way. It has to be linted. So we'll get into all this before. You need to account for refactoring. You need to make sure your code is part of the system's design in some way, shape, or form. So all of that kind of together creates a more cohesive code base. And when you're working on a team of 5, 6, 7, 10 developers, that becomes paramount. Because if I write one type of code, like if I write in one style and, developer C writes in a completely different style, and I need to go and maintain whatever they wrote because they left the team or they're on vacation, it's going to take me exponentially longer to spin up. We're just disconnected. Like, we're not writing the same thing. We're writing in two different languages almost, even though it's all probably JavaScript or TypeScript. So it's really important to try your best to be able to stick to these metrics and these standards. And I can guarantee you, if you join a team and you try to do this, it's going to set you apart from a junior perspective, because this is where juniors struggle, like just flat out. A new developer comes onto the team 100% of the time. They're going to have situations where they just didn't read the documentation. They didn't look at an example pattern. They didn't do the linting proper, like, etc. Like these little things, not the code. Usually the code is written and it's fairly good. Like it works. That's not usually the problem that I have. It's usually the fact that they just haven't adhered to the standards and principles of the code base and the other members of the team.
I do actually want to mention something else here, because we're going to obviously be talking about, code quality, but a lot of it is through the lens of the technical side of things, right? Like the linting, the testing, making sure edge cases work, all those type of things. But there is like another part of this as well, which is the human effect, I guess you could say, of code quality. And it kind of comes down to communication and proper planning, because code quality can go downhill when the code isn't correct, but it solves the problem that someone thought was presented. So I'll explain that. So let's say someone says, okay, I want a slider and I want there to be, for the sake of simplicity of this example, I want there to be 4 slides and I want them to change every 100 milliseconds. So the person goes in, the junior developer, doesn't matter, senior developer, someone goes in and they code up a slider, let's say in JavaScript from scratch as requested. They do the 4 and it automatically transitions every 100 milliseconds. But then, feedback comes in and they go, no. I want the actual slides to transition in amongst themselves. Like I want there to be like an animation where it changes to slide 2. That's actually every 10 seconds and then every 100 milliseconds of transition. See, that's already getting muddied up. It's already getting confusing. And then usually when that happens, it's like, okay, the person isn't necessarily going to be disciplined because they did the wrong thing because the request was unclear. But now it's like, okay, like we're not going to necessarily add time to allow this person to sort of fix this. So we just need to sort of fix this in the QA stage. And so now code is being reused and it's being retrofitted and it's being kind of janked together, MacGyvered together, really, in order to be like, okay, what parts of this code can we use to now get this new objective done? And whereas in the case of a slider, it's not, super crazy difficult, but you can see how a request that's more complex than the one that I said, for the sake of an audio show, can get really muddied up, where it's like, oh my God, we have the transitions on the wrong thing. Now all our tests are wrong. Now this is wrong. Now that's okay. So now let's try to, for the sake of example, like let's try to wire this to this, let's try to use this function, we'll rename it. Oh, now there's errors, and start putting all these things together. And that's actually because of like lack of organization, whether it's team organization or like another team that, you work for, that the devs are working for, however your company is organized. It's really important to get the beginning kind of down pat, because it can affect the quality of the code, even if the person knows all this stuff, even if they know how to test, they know how to lint, they know all the standards, like Mike had mentioned, they know how to adhere to those standards. If you're in a rush, you're in a rush, right? Quality will naturally go down. And like we've already mentioned, you don't want to just be rushing. Like you want to be going, quickly, but it's kind of like the slow is smooth and smooth is fast kind of, cliche or metaphor, whatever you want to say. You kind of want to adhere to that. But when you are at the 11th hour and, it's no longer slow is smooth, it's more like we got to just go fast and start taping things together. I mean, yeah, like code quality is going to drop, and maybe you won't even be able to write tests and things like that. So having things planned out well in the beginning, on top of all the things that Mike's going to add to in this episode, it really is important to code quality, but also to realistically like the longevity of the code, because the more features that are taped together, as we then, like, let's say we go and we build one, like version 1, and then we go, okay, everything's good, it's all working, but one of the major features is taped together, but nobody knows. And then we go, okay, next thing, part 2, version 2. Well, if we didn't fix our organizational process and we have the same problems, now we have another feature that's taped together. What happens when one taped together feature has to interact with another taped together feature? Version 3, now we got a big problem, because now we got this leaning tower of, taped together code. It's going to fall apart, and this is a mess. So it's just, I wanted to mention that sort of human effect, because it doesn't always come down to the developers. And Mike and I have had this several times, right? When a part of our job is we try to translate a client's request, non-technical client, to a coding request, and you'll build it, and then they'll go, well, like that's like absolutely not what I wanted, and you'll be like, yeah, but you specifically asked for this, like you used the right terms, and maybe they've gone to ChatGPT or read a blog post to try to communicate with us, but have not understood what it is they've requested. And so now it's like, well, I guess we're just rushing this new thing out and retrofitting what we can, and it ends up every time being a mess.
So it's a very good point, and something that, like, no matter how stringent you are to this stuff, it's going to happen. And I do have a section in this episode to address that. It's going to be on refactoring, and that should be 100% part of your process, because of exactly what Matt's saying. It's going to happen where something will be passed down from the top being like, we need this tomorrow. And you're going to write shitty code. Or not even shitty code, just fast code doesn't adhere to every principle, not tested, etc. And you're going to put it out in production, and it's going to work, and that's great. But if you don't address it on a consistent basis, it's going to end up being a disaster, just like Matt said. So yeah, spot on. But the first thing to like prevent that, right? Like the first stage of code quality would, to me, be testing. If you have a good set of tests written for your application, the idea of introducing bad code, right, even a code that works in one scenario, a test should be able to test multiple scenarios and detect which scenario it doesn't work in, right? That's kind of the idea of testing, and to root out that initial layer of problems. So with testing in web development, it's not usually the highest priority thing, honestly. I've written tests 100%. I've written unit tests. I've written end-to-end tests. I've written image regression tests. I've written a bunch of tests, but it's been very much like a secondary thing. Whereas in other languages, like if you're coming from more of a hardware level thing, if you're coming from a banking system level thing, if you're coming from any sort of medical field, like anything outside of web development pretty much that relies on mission critical systems, testing is paramount. And usually what you have is stuff like test-driven development, where you like literally write the test first, and then you write the code that can fit the test and stuff like that. In web development, that's not as popular because it mostly just slows you down and doesn't provide enough benefit. Like we have this outside of web development, you have this thing called like 100% test coverage, where all of your functions are covered in tests. No matter what you write, you can run all your tests. It should test everything. It's almost redundant. Like that would be kind of crazy to do in a web development environment where it's going to slow you down way more than it's going to benefit you, just because a lot of our systems just don't need that. Like if a user clicks on a button and the page doesn't load, it's not going to change much depending on the button, right? So like we just don't need to spend twice the amount of time writing that test for that button when we could spend that time writing a feature or writing a more important test. So this is where the nuance comes in. I'm very much a proponent of like, you need to write tests around the critical components of your application, but you should not aim for 100% test coverage. That is a fallacy and that is a pitfall. And that is something you could fall into that would very much delay any project you're working on, or potentially just cancel it because it'll never get done due to just how long it'll take you with the unnecessary parts of it. But again, tests are important. So when you have critical systems in your application, something like payment processing, right? That would be a critical system of an application, because if someone can't process a payment, therefore they can't use your application. So around payment processing, you should probably write some tests. That's just, rule of thumb stuff. If you have stuff that like, hey, I need to submit this form, and if a person isn't able to submit that form, then there's probably going to be issues with them being able to, go into our application or get feedback or whatever, then you write some tests around that. So you locate the areas of your application that you deem critical or your company deems critical, and that's where you start focusing on your tests. Now, I've mentioned a few different testing types like unit testing and end-to-end tests. That's just two of them. There's like a lot more: image regression tests, integration tests. There's a bunch more. I'm focusing on unit and end-to-end for this one, because I think those are the most important two for someone just starting in the testing field. The rest of them are important. I'm not going to say that they're not. Like integration tests definitely have a huge part in the industry. But if you can get down unit testing and end-to-end testing, everything kind of builds on those two. An integration test is more like a unit test and stuff like that. So it's important to just get the fundamentals down, and then you can build on that as you go. So with the unit test, what you're looking for here is you want to test small critical functions. Right? So you've written a function, and if that function is critical to your application, you've already identified that, you want to write a test for it if a set of inputs will produce a predictable set of outputs. What do I mean by that? If it's a, for instance, currency conversion function, right? You would be able to test if, at this rate, at this currency rate that you input into it, and at this amount, it should produce this output, like this amount of money for whatever currency. So a set of inputs should produce a predictable set of outputs. That's your indicator where you can wrap a unit test around it. If the function inside is completely random, or like has some sort of external variable or something that just you can't account for in a test, or it just does too many things, then that's kind of an indicator for you that, hey, that's probably not something you can write an easy unit test for. And it might be an indicator for you for maybe breaking down that function, refactoring it into smaller functions that you can unit test. So that's kind of a double indicator there. There's another areas like when you're writing code initially and when your application is just being built out, a lot of times a function might not be done yet. So like you might think that like, hey, the outputs of this function are this right now, but next week we might be changing this and the outputs might be completely different, even though, the inputs are the same. That's another indicator where you'd be like, okay, I need to wait a little bit to make sure this is stabilized and then start writing tests. Otherwise, you're going to be writing catch-up tests, and that's just a waste of time. It's a double, you're double writing for no reason. It's better to wait for a more stable, like, okay, this is what, no matter what, tomorrow, the day after, a year after, the output of this function is going to be this. That's a good indicator for writing unit tests. And there's plenty of frameworks you can use for writing unit tests. Vitest is a very popular one that's really quick right now. Jest is another one. Bunch of them. I'm not going to get into how to write a unit test because this is an audio podcast and that would be a complete waste of time for everyone. But again, if you're into it, there's plenty of stuff online for getting how to write a unit test across.
I have a question here. So, so to me, I've never written a unit test, but most of my stuff is I'll, write an email form or something, which is a very common one, have a custom email form. And I'll think of okay, this is supposed to have a number input. And so I'll go and be like, okay, what if I type a number, right? These are the edge cases. What if I type a number? What if I type this? What if I type that? What if I type the input that is expected? Okay, it is working. And so I'm probably not the only one thinking that okay, if I were to write a unit test, it would be doing the same thing that I'm doing. And it would miss the same edge cases that I would miss in my sort of real world testing that I'm doing hopefully in some sort of dev environment. I understand what you're saying. Like the unit tests are supposed to be done on the more complex kind of components, but wouldn't you just do the same real world tests anyway? The way I'm thinking, and so this is the world I'm coming from. So like what I'm saying might be kind of dumb, but like the world I'm coming from is like, I used to like work in a hardware lab where like the developers would do an upgrade to the firmware on some hardware, and there would be like 100 devices literally sitting in a device. Like, so 100 of our hardware devices sitting in a device that has like, cables and things all connected to it. And every single time, an update would go, somebody would go in and say, okay, run the test, and it would test it on those devices. And, those devices were complex. There's temp sensors, there's batteries, there's this, there's that, there's this, there's that. So there's like 100 million things to test. And so it makes sense to have those things be automated, because you also might have a sporadic thing, right? Where you're testing on 10 devices, 9 devices, it passes 1 device, it doesn't. Why is that? Oh, this because we upgraded from this to this on this device. Like, what's unique about this device? There's a heck of a lot of stuff there. Whereas, like, I know that you said this too, like a lot of the time when you're making a website, it is something, quote unquote, like non-mission critical. Like if someone's going through a tutorial and they get, 9 out of 10 steps through, and they go click on next on step 9, expecting to show step 10, and then step 10 doesn't appear, I mean, it's not the end of the world. Like, even if the site is unusable at that point, it sucks, but like, it's not like, oh my God, what are we going to do? This is a total disaster, et cetera, et cetera, et cetera. I guess like that's kind of my question is, like, coming from the hardware world, it makes a lot of sense, because like devices, like smartphones or, whatever, PDAs or whatever you want to say, I'm dating myself, but like older like devices or not older devices, but like complex sort of like general computing devices are really complex, right? Like there's a lot of stuff. Like if you were to say, I want to change the look of like the clock on an iPhone, well, what's that going to do to the battery, right? What's that going to do in different time zones? Like there's a lot there. I guess I'm just like struggling with, like, I get why you write tests, but I don't know why you just wouldn't do it in the real world, because you're not doing it like in the hardware world, where if I changed that clock icon, I would literally have like 10 iPhone 11s, 10 iPhone 12s, 10 iPhone 13s, and I don't know what number they're on now, 10 iPhone 14s, and I'd run and like run. Okay, this one, this one we're emulating is in Germany, this one's emulated in France, this one's emulated in Canada. We need to test, and have like redundant tests. We'll have like 10 that are all faking or emulating the fact that they're in Canada. We'll have 10 of those devices running to see, because maybe it gets cut off because it's, English Canada is slightly different. And you know what I mean? Like there's so much stuff there that having a bot do it makes a heck of a lot of sense. But with a website, it's sort of like one of the reasons why many people start with web development is because you're so close to the visual element already. Like you're so close to being like, one of the first things you're going to do is, show hello world on the screen, and it's just in your browser, and like every modern device, and even, from a decade ago, has a browser. And so it's like so accessible from a visual perspective that I guess I'm just sort of struggling with the real need for a test. And I know that people are like super into it, but I just feel as though like you should just do it, right? Like in real world.
Great question. So one thing with unit testing, it's not really testing the real world side of things. It's testing the code side of things very directly. We're going to get into end-to-end tests, and that is the real world side of things, and doing like the bot thing that you're saying with the kicking off a bot and going through. So there is a little bit of a nuance there where you're testing much smaller functions than testing the entire form input of like a human actually entering something in and output. You're testing in like the verification process of that input only, right? So the reason you do it is because, yes, absolutely, a QA tester can go in and test the same things that a unit test can do. But if you have 100 forms and you change one thing in one form that's linked to another form, a human would have to do that every single time to catch it, and they won't. I just like 100,000% tell you they won't catch it. So what a unit test does is that it gives you that error check before you get even to deploy anything out there for a human to start testing. It's run automatically on any kind of condition. You can run it from a CLI. You can run it on save even. Like there's tests that run live as you're writing code that'll continually test your code. And so like it's a very immediate output and a very immediate like, hey, this is wrong. And it's impossible, like again, if you have 100 forms on a site, to have a human verify those same like different kinds of verification methods and have that be effective or cost effective and catch everything. So that's why we write tests in general, is that we can't rely on humans to always catch the same things, even though, yes, you are correct. Like they are doing the same thing over and over again. Yes. But humans in general are not good at that. So testing is better at it. And again, if you have a form that doesn't really matter, that's your indicator that you probably don't really care about writing a test for it. That's the other part of it. So that's why I'm saying like you shouldn't 100% adhere to the let's write a test for everything rule. It should be a very like, hey, is this mission critical? Write a test.
So let me ask you this then really quick. So like based on the code base, like I don't know how much you could share about this, but based on the code that you are working on today, or even in the last year or something, like choose a time frame and sort of share it if you can. What is the percentage, just roughly, I know you haven't like tallied this up. What is the percentage of like code functions, whatever metric you want to use, that you've actually run tests for? Like, is it 10% is considered core? And then you've only, had to test 10% of code. And then the rest of it is just like you going in and actually doing it. Or is it way, way more?
Yeah, it's closer to 10 than 100. So just to be frank, so right now, our team that I'm working on right now at Cypherin is going through a testing week period where we're going through and writing tests for our mission critical infrastructure and applications and that we have neglected, right? So we've been writing tests along the way, but it's been very like sporadic, probably less than 10% right now at this point, honestly. We're trying to get it to the point, we're not hitting percentages, like we're not actually tracking percentages, but I would say if you put a gun to my head and ask me a percent, we're probably aiming at in between like a 20 to 30% directly on the, like, is this mission critical? Do we care? If this fails, is the user not able to use the application, right? Or is the user still able to use it and it's just an inconvenience? And a lot of it isn't just an inconvenience. Like, hey, if the video player doesn't show a subtitle, for instance, that's an inconvenience, right? Like it sucks for a lot of people, but it's an inconvenience. So whether that's a secondary test that we would write, not a primary test. If we have time, we'd write it. But if the video can't play, then that's site breaking. Right? So we write a test around that to make sure that the video is there and the video can play, if that makes sense.
Another example, just to build off of yours, would be, so the thing I thought of immediately was in a bank app. So obviously a bank app is going to be really, really tested, or at least it freaking should be. But like, let's just say for the sake of example. So if it's something like, we're going to run a test to make sure that this output, whatever it is always a number, because like this better be a number and not a string, because this is like our transfer code where we're transferring from account to account. So we're going to make it so that the test, it does all the inputs and outputs of the forms or whatever it is the people are filling out in their app or in their web app, or again, whatever. We want to make sure that this particular test always checks that number at the end is an integer. Is that an example like of something that would be mission critical? Because if it's not and it's a string, like that's bad. Because then you're like trying to add a string to your money and it's not going to work, and it's going to be a big. So that would be an example that just popped in my head as you were doing the video example. Okay, so that is an example of like mission critical. Humans may miss that too, because they might go, oh, it still shows 10,000, but not realizing it's 10,000 in text as a string. Okay,
that's exactly it. So like you test those kinds of things, and it's not only about humans missing or not missing. It's also about like, hey, I've tested it once. I go off and do some change to my code somewhere completely different, right? Thinking that this can't possibly affect this.
Right.
What I don't realize is that someone else has at some point linked these two functions in some way, shape, or form, and I've changed this function, which has now broken this other completely unrelated function that I didn't think was related, right? And so I wouldn't even ever think about doing a QA test on that. But if I have an automated unit test set up, well, it's going to run no matter what, and all of a sudden it's going to pop up red. And I'm going to be like, oh, well, that shouldn't happen. That's a weird thing. And I would go back and go look at it. Again, if I didn't have that test written, that happens all the time, right? Like this situation that I'm mentioning happens like nonstop in software development, because people don't realize how scoping works. People rely on like interconnecting functions too much. Like there's inheritance issues. It just happens. And so if we don't test these critical functions and we go about our daily lives thinking that, okay, I'm only working on this like subsection of code, so I'm going to test, I'm going to build it, test it myself, send it to QA, they'll test it, and then something else breaks. Yeah, that's where you want to catch stuff, is that interconnection.
So as a real world example for you, because you've talked about this in the past, you were dealing with those really bad Android devices, like hardware wise, they were like, not good power wise computationally. So one of the things that you found eventually was that the players like weren't stopping. Like the players were just like keep playing, even if you were like, okay, players stop, now start a new player and play video 2. It wasn't stopping that first one. It was just sort of like idling in some way. And of course that was really mission critical because those devices, not computationally powerful, require as much RAM and computer CPU power, etc. free. They need the resources free, and so they need that first session to exit. So like I would imagine that one of your tests eventually would have been, okay, like, we went and we changed something totally unrelated. Like we changed like the title, but for some reason the title kept that window in focus. And so that stupid video kept playing, even though I told it to stop. So one of your tests might be every time a video plays, tell me how many videos are playing. And if it's ever 2, okay, that test has failed. Something has caused like that first test to not exit properly, or that first video not to exit properly. So that would be something that would run every time you would change slides or whatever it is you were doing at the time.
It would just run automatically with like, your code, your changes in your code and stuff like that. So yeah, that's a good example. You could write a test that could do that would just test the is playing function.
Right. Okay.
Right. And then just like iterate a counter and that's it. So yeah, good point. We didn't write a test like that. We should have probably, just being blunt.
I was going to say, I thought for sure you were going to be like, oh yeah, we wrote a test like that, but no.
No. We very minimally tested application right there. I did write some tests, but they were very rudimentary and I wish I wrote more. It would have probably saved me a lot of headaches, but just was very junior back then. And again, that's why I'm trying to explain why you should test a little bit, or you should kind of dive into testing as much as you possibly can without impacting your output as much. This is the balance. Like if you're testing everything, that means you're writing twice as much code, sometimes more. So this is where you have to balance. So that's unit testing, right? Like we just talked about unit testing. I want to touch on end-to-end tests as well, because I think they're almost equally as important, if not more important in web development. So end-to-end tests are more what you were talking about before, where a human actually goes in and tests some stuff. This is like a bot. You're creating a bot that would go in and test your application as it were in the real world, right? So what usually happens with an end-to-end test is that it packs in a version of Chromium inside of it. It runs your application, all the dev servers and all that. And then you set it to do actions on your website. So one of the actions might be hit the about page. And then the next action might be scroll down 20 lines. And then the next check might be, so you have actions and checks, is check to see if this div is visible. And that would be like a pass or fail. So if the div isn't visible, then something has gone wrong during those set of actions. And it's the same thing you could do across the entire page, where like you can log in and the next page check to make sure the dashboard is visible, and etc., and keep going down the page. And these tests are much more robust. They obviously take a significantly longer time to run. Like you're not going to be running an end-to-end test on every save of your code. This is something you would run before you push your code up. It's equally as important. They're a little bit more time consuming to write because they interact with multiple different elements on your page. But the advantage here is that you're acting like an actual person. You're putting your app through the steps that an actual person would put through. So you can test edge casey things, or you can test basic functionality things that could be affected. Again, back to my point before, random change over here all of a sudden impacts this page that should not have been impacted, right? These are the kinds of advantages you can have if you write a good coverage end-to-end test. My recommendation is to write multiple end-to-end tests that can run in parallel, rather than like one massive one that takes an hour for it to run and then fails randomly at different spaces. So try to keep your tests to be like function to function. Like you're testing the login functionality, you're testing the dashboard functionality, you're testing certain features, right? You're not testing every little piece of your application in one test. You're splitting your tests up into multiple tests that run in parallel. So end-to-end tests are a good thing to have in your playbook. Some testing frameworks for that, or the one that we use, is Playwright. There's plenty of others that you can use, but Playwright is good. Like there's this automated testing function where it'll actually like open up a GUI almost and allow you to run through your application and then record your steps and then turn those into tests. And so sometimes you'll have to put like waits in. It won't detect how long you waited for something and it'll just fail. So you'll put in like, okay, wait for 20 seconds for this page to load and then test to see if that's there. So you can do a lot with it. And you can do a lot of it automated, a lot of it handwritten and stuff like that. And it honestly, like for me, these are really, really important, because before you put anything out there, rather than have Jimmy or Jill out there doing all these like tests redundantly. Not that it's not still necessary to have a human look at it, but this will make you much more confident in launching an application because, again, it's that cross-pollination. You change something here and it breaks something there. These tests can catch that.
I was actually going to ask if there was like a no-code tool for some of this stuff. I mean, a lot of the tests are going to be really specific, but a lot are going to be generic, like, testing if this video plays, testing if like the RAM hits this much usage or something.
Yeah, absolutely. Exactly. So like there's probably other no-code tools that I don't even know about, but just like the one that we use is just literally like use their website and then it'll record your usage and write a test.
And it will probably only get better with AI because AI will understand what you're doing and then be like, oh, the person's waiting for the page to load. You wouldn't even need to put a wait in there.
I haven't even put this in here yet, but I highly recommend trying to use AI to write unit tests as well, because it's pretty good at reading your code and then interpreting what it can test in your code, right? Interpreting what edge cases it needs to test as well. That's another key one, is like for you to think of edge cases is not easy. Right? Like, hey, what's going to break this? You want to know what's going to break it because then you can catch it. Then you can say like, okay, this is good that it's breaking or it's bad that it's whatever. So generating edge cases, AI is really good at that. Generic unit tests, really great at that. So yeah, utilize AI for this 100%.
Devs, this one's for you. I've got 30 seconds to tell you about Wix Studio, the web platform for agencies and enterprises. So here are a few things you can do in 30 seconds or less on Studio. Integrate, extend, and write custom scripts in a VS Code-based IDE. Leverage zero setup dev, test, and production environments. Ship faster with an AI code assistant. And work with Wix headless APIs on any tech stack. Time's up, but the list keeps going. Step into Wix Studio and see for yourself. Link in the show description and in the show notes.
Next thing here, though. So we're done with testing. That's the first kind of line of defense. To make your code more readable and to make it more conformable and easier to conform, I should say, you use something called Prettier. So Prettier formatting is an auto-formatting tool that you can install into your IDE, and it usually just does visual consistency checks. And essentially what that means is like, if you use spaces, but your Prettier configuration is tabs, it'll automatically convert your spaces to tabs as soon as you hit save or as soon as you run the Prettier config. Have you put semicolons at the end of your lines? Is that a requirement? Yes, it'll automatically put semicolons. Do you have trailing commas in your JSON? Yes, it'll automatically put trailing. All these little things that would take a person time to conform to, Prettier automatically conforms to it. And what that allows you to do is that you could stay in your comfort zone if you're a tabs guy or a spaces guy. It doesn't matter because your Prettier config will solve that for you. Right? Like you can continue using whatever you want to use. And as long as your team has agreed on a configuration, Prettier, the tool, will automatically configure everything visually for you. What it does not do is check if the code is right, check if it runs correctly, do any sort of performance stuff. Like, this is a purely visual thing. And it's important, really important, because when you're going in and reading someone else's code and someone has tabs and spaces, someone has semicolons, it throws you off. I know it sounds pedantic, I know it sounds nitpicky, but it honestly, like, it throws you off. It's like you're reading a different book, whatever. But when everything is formatted the same, it's like you're reading the same code base. And it's just easier for you to work together and work on the same, like, different files, but feel like it's the same project that you're working on. The other benefit of it, I'm sure that people will relate to this that have been in the industry for a while, is a lot of times pull requests, when someone does a review of your pull request, half of it's going to be filled with a bunch of nitpicks of like, you didn't put a semicolon here when you should have, you didn't put spaces here. These should go away 100% if you have a really good Prettier configuration. Because any sort of nitpick stuff, if it happens multiple times, should go into the Prettier config and automatically be solved on save. And so it should never be checked in, because your Prettier formatter should already catch it. If you're a team lead or you're reviewing someone else's code and you're making a bunch of nitpicky comments, sometimes it's better to, instead of making a bunch of nitpicky comments, to go in and change the Prettier config and ask for everyone's approval on it, right? Like being like, oh, you know what? I've seen that we're kind of not standardized on the spacing of these files or the spacing in between lines here. Maybe we just standardize on it, let the Prettier handle it. Like, allow these tools to help us focus on the actual functionality stuff when we're reviewing. I hate nitpicking in a pull request because it's just a waste of time for everyone.
I was actually going to ask you a question here. So with that, like, you go in there and you change the Prettier, Is that set at a local level in your IDE, or is that set in the project? Because, if you're trying to, let's say, submit to open source, would they run it through their Prettier? Do you have to download their Prettier? Like, what's sort of the general workflow there?
Yeah, so it could be run multiple different ways. Typically, it's project-based, absolutely. It can also be run on like a git commit, right? So when you push something to a repo, like for an open source project, like you mentioned, it could be run during that push. I don't like that. I think it should be handled in your IDE based on the configuration file that the project provides. It just feels weird for my code that I've already saved and pushed up to be all of a sudden different. And I feel like it could introduce unnecessary bugs. I don't know if it will or how, but like it could. So I prefer it being local, but with the project's configurations, which is the typical setup.
Okay.
Yeah, you'll just throw a config, like a JS config file or a JSON configuration file in to the root of your project, and it'll automatically be picked up.
So if you were to say, let's say it was, built in, and let's say I just like pulled down what I needed to pull down from an open source project, I change whatever I need to change, and then I submit a pull request. Does it automatically like go through the Prettier when they do the build, so they won't nitpick what I wrote? Like, what's that look like?
They can set it up that way. But like I said, usually it'll be done like essentially you would write your code however you want to write it. You would hit save. And most people have it set up that it prettiers on save. And your code will be formatted the way that they need it to be formatted on save in your local IDE.
I was thinking it was on build, because I was thinking when you go to submit it, like you wouldn't rebuild their app and then send them the built app. So I was a little bit confused.
Yeah.
Okay.
It would just be your file, the one file that you changed, you save it, it reformats to whatever their settings are, and you commit.
Okay.
Fairly simple. Like, it's a fairly painless process as long as it's set up correctly. There can be some difficulties with setup, as we've had with our project, but there's like 1,000 guides online on how to do it. It's not too hard. Okay, next part here, part of the code quality journey, linting. So linting is very similar to Prettier, where it does like format your code and stuff like that, and it can do stuff that Prettier can do as well. Like, you can set like certain spacing criteria and stuff like that. But linting, rather than just being a formatter, is actually like a set of rules. So this is something where you set it and the code isn't like formatted, it's analyzed, and it spits out a report telling you, hey, here are the errors or the warnings in your code. And linting can also fix those warnings to a certain degree. They can't fix everything, but it can fix those warnings. You can run like a lint -- fix all, and it'll go through and like and fix all those warnings with whatever the linting is set to. But it is more of like a analyzer, right? And what it's doing is it's not only doing formatting checks, it's actually doing like usability check, like actually doing a check on if something will work or not. If you've declared a variable outside of a scope and then use it internally inside of a different scope, your linter should pick that up. A lot of linters currently run automatically in your code rather than you like having to like click, like go into the CLI and go lint. Essentially, as you're typing, it's automatically trying to lint. And that's why you see those red squigglies in IDEs, is that's your linter telling you, hey, there's something wrong with this from a functionality perspective, function perspective. This is weird for JavaScript because JavaScript, again, doesn't have a compiler. And so a compiler is usually the thing that catches that. So the linter is kind of trying to limit the bugs that you're writing in your code, and also setting some rules, even outside of bugs, just on how you write certain things. Like, for instance, the rules that it could set is no unused variables. Now, unused variables aren't going to break your application. So if you have like let x be y, c, and only use x in your application, nothing's going to break. But that's memory allocation that's not needed. So you could set a rule in your lint being like no unused variables, which means that anything that's unused will be highlighted with a red underline. And when you're trying to like commit, you can actually set a bar being like, hey, you can't even commit this file unless you fix all your linted errors, right? So that sets a bar for the entire team to be like, okay, we need to actually fix everything before we put this into production. That can be a little bit of a barrier sometimes. So again, when it's kind of nitpicky, like the unused variable stuff, that actually introduces some issues, right? Because now people are going back and having to fix code that works. So this is where people are split a little bit on like, do you put a hard commit? Do you put a hard stop on allowing people to commit? Do you just give it as a warning error? or just as an error, like without limiting the commit, et cetera, et cetera. There's many different paradigms. I think certain things, like the stuff that will break your code, yes, you shouldn't be able to commit that code, in my opinion. Rules, that's different. I think that should be set there and then caught in a PR if it's important. But again, you're allowed to commit it and then go back and refactor it later. But it's a personal thing. I could be wrong on that. And I know people push back and be like, well, you got to make your code as readable as possible. You got to put as many limitations in. I get it. I get that. And to make it conform as much as possible, we're talking about code quality this entire episode. I just think the more guardrails you put up, the harder your team can innovate, the harder your team will be able to build with velocity. When there's a emergency bug, yes, like you can get around it by putting in some flags, but like they're going to be thinking about how to get, through the linting. I don't know. It's just, I want to allow my team to have the velocity if they need to get around this stuff. But also when it's a regular development environment, I want them to take the linting rules into account and write better code. I'm split on it, right? But it's just the reality of it.
Can you give an example? Like you gave an example of the rules, but what about like what type of bugs would it find if you're like actively writing?
Oh, like tons of stuff. So TypeScript, right? TypeScript uses a linter. So any sort of like typing issues. So let's say you declare let variable a equals cat, like a string cat. And later on in your code, like 20 to 30 lines down, you try to assign a number to it. It'll detect that and be like, hey, you've already declared this as a string, like you can't assign it to a number to it. Your string will, like the variable will break down here. So stuff like that, like any sort of error it can detect. Like I said, with the scoping, you're trying to use a internally scoped variable from like a loop outside of that scope, outside of the loop, it's not going to work. Like this is a new variable, so it's gonna tell you like you haven't declared this variable yet. That'll be an error when you hover over.
Okay, that's interesting. Okay.
Yeah, pretty much any like tons and tons, like there's any sort of error you can think of in JavaScript, it'll detect it.
What would you say, like, I know that the prettier and the linting is different, but what would you say for someone who's like, say, self-teaching? Because this stuff sounds like it's really team-based. Like, do you enforce it? Do you not? How do you want your code looking in terms of the prettier? Like, is there a thing that like someone can do if they're self-taught to just be like, hey, like I wouldn't mind playing with a linter. I wouldn't mind playing with a prettier. Like, what would you recommend as like kind of a jumping off point for those?
So yeah, that's a good question. So for like any sort of framework you use, for instance, React, Svelte, SvelteKit, Next, like whatever framework you use, a lot of them have the option or are built in already with prettier and linting already set up for you in like a default configuration that everyone is kind of basing their stuff on. So in my opinion, that's probably the easiest way to get up and running with it. When you're just like, install it from the CLI, create a new app, and you're good to go. Like you're pretty much already set up with linting. It's already built into your IDE. It's very much in the background in that sense. And you're like, oh, this is cool. Like everything is read now that I've written this incorrectly. Like that is very much the case where if you don't know that it's there, you might not even know what it is. You might just think like, oh, the IDE just knows my code is wrong. Well, that's not really the case. The IDE is using linting to know that your code is wrong. And the linting is set up from your project, which is part of the React installation or part of the React Create project code. Like the intricacies are the part that is a little bit more complicated. And then if you want to configure it, there's a configuration file in the root of your directory. That stuff you need to kind of go out of your way to configure. But my recommendation is to use the very basic configuration that's available to you that comes bundled with these frameworks and just see what it does. Like see like, hey, it's actually like, yeah, I can't write a variable outside of scope. It'll tell me I can't do that. And then be like, oh, you know what? But I kind of want to be able to limit my console logs, for instance. So console logs are very good. Everyone uses them and there's nothing wrong with them. But you don't want them to get into production unless it's very explicit. And so there's a linting rule for no console logs. And that'll do is that before you even commit, it'll check your file for console logs and it'll tell you, hey, there's an error. You have a console log in here. You're trying to commit it in. And so it'll stop you from doing that. So those are the kinds of things that you organically can add to your configuration and kind of get better at it without having to like, boom, I'm now a professional linter or a professional lint configurator. You don't want to get to that point right away because it's not going to help you that much from a productivity perspective unless you're actually using the code and know the code really well. So yeah, hopefully that helps understand where linting kind of fits into this place. With that, we're going to move on to the last thing here, which is refactoring. So refactoring is rewriting your code to be cleaner and more maintainable after it's already been written, right? What you're doing with refactoring is you're trying to simplify functions, reduce redundancy, split up huge functions into smaller ones, componentize a large page, etc. Like the goal of refactoring isn't to make stuff more performant. I should be very clear here. You're not changing performance. You're not changing the function of your code. You're just making it more readable, more maintainable, easier to work on, right? And you're removing stuff that isn't used, essentially. Like you're getting rid of code that's not used.
And you're not doing performance when you do like some of that stuff?
Well, I mean, inevitably, if you're getting rid of code that's not used, I guess that could make your package size smaller, but that's not really the goal of refactoring.
Okay.
When you're doing performance work, you're doing performance work. Like that's different than refactoring to a certain degree.
Okay.
Right? Like you're writing functions in a completely different way that is more performant rather than just looks cleaner and stuff like that. Like refactoring is like, hey, this needs to look cleaner, not so much like this needs to perform better.
What's the line there? So what I mean by that is if I write it this way, it's going to be, more functions, more of this, more of that. It's going to be slightly less performant, but it's going to be way easier to read. Like what's the line that you toe there?
Good question. So the line to me with that kind of stuff is that if the performance that you're changing isn't going to affect a user's experience in any way, shape, or form, then I'd rather it be readable than performant. So for instance, if you're filtering an array of 3 items, okay, you can write a super performant array function that's like, 20 lines of code. Sure. You can write your own filter function.
Right.
It'll perform better. Mm-hmm. But you're filtering 3 items. And so for a user using a dot filter on a JavaScript array and a custom array function that was written by hand that's 10 times as performant, the user's never going to know the difference, period.
Right.
Not possible. Like you're talking, nanoseconds, microseconds, whatever. But if the function could grow, if the array could grow to 1 million items, then you go towards performance.
Okay. You're more worried about just like what the end user is going to experience because like effectively the dev UX, like it makes a difference too. Because if your UX as a dev is bad, you're going to have trouble making technical changes, but you're also not going to want to work on that code base. You're also going to not want to be there as we found out on our own projects where we make things a mess for us and we're like, yeah, that'll be fine. And then we try to go back to it and either A, it's too hard to go back to, or you just don't want to because it's like, man, that's such a pain in the ass to actually change, fix, and work with.
Yep. User experience is number 1. Number 2 is dev performance. Yep. Dev experience, right? So like if the user experience doesn't matter which way you write the function, then I'm going to lean towards the side of dev UX every time.
So like we have a client right now and like I'm not doing a web app, I'm doing a website for them, marketing site. And they're all about performance right now. And even though we've sort of increased the page speed score to an acceptable level, they just have a really, really media heavy site. And so there's not much that I can do without, paid plugins and stuff, which isn't in the budget. And so I've gotten it to a point where I don't personally think, and I've asked other experts as well, I don't think that we're being affected by the performance from an SEO perspective, which is, again, really important for marketing. But yet, this client is like absolutely adamant, like this thing needs to be performant. How much are you on that performance side? Like, are you, obviously, like I know you mentioned like your dev UX versus performance, but are you using these tools like this person's using where they're using page speed insights as well as others to like constantly check things and be like, oh, there's a problem here. Oh, this thing needs to be, we need to fix this. Like how kind of like anal are you there? Because that would be a part of refactoring as well, I would imagine, right? Where it'd be like, oh, there's actually like the title's being declared twice, which may not get detected by the linter. Because it's not really a problem, right? You're just kind of like redeclaring it later. Like, what's your thought on that? Like, when you're building these apps and like doing the refactoring and stuff, like, are you finding yourself really going into, like, I don't know, the SEO performance, you could say? Like, and I don't mean SEO performance as in people showing up and like how many impressions you're getting. I'm talking about like you're super worried about the user experience. How worried are you there?
It's a great question. I think I'm worried about it, but not to the level of checking page speed insights on every load and stuff like that. I think it's very easy to just go into your browser, just click on the network, like, inspect element, the network tab, limit yourself to 3G, and just go through your application. I don't expect it to load immediately. I don't expect stuff to be like snappy, right? But I expect it to be usable. If there's a 20-second load somewhere, that's a problem.
Right.
If there's a 5 to 10-second load, I'm okay with that. 3G speeds, people can wait.
I don't even know what you'd really call it, but like this SEO performance mode, people are getting like super into it, right? Where they're like, oh my God, the first paint is really bad. We have to like do this and that. And meanwhile, like in real world testing, and even if Core Web Vitals is involved, like let's say Core Web Vitals is passing, people are like, oh my God, this is like, it's like an extra like quarter of a second. Like, what are we going to do? It could be way, way, way less. It could be like 1/10 of a second rather than, a quarter of a second. What are we going to do about this? And like the amount of time you would spend getting it to go, down 15%, right, from 25 to 10. The amount of time you would spend is so much to gain so little performance. And it comes to that point, right, where it's like you're towing that line between like dev UX, the user's UX, the SEO people are going to be involved too, right, where they're like using their SEO tools, SEMrush or Ahrefs or whatever it is, and then they're worried, oh my God, there's like 18 errors, but they're not real errors, right? It's not like the code's going to blow up. It's like an SEO error. And so like this is where a lot of my refactoring, this is why I bring this up, is that a lot of my refactoring ends up in this area where people are using those SEO tools. They're reading through what is declared as like major errors, but in reality it's just sort of like, it's almost like a flag, right? Like a lot of SEO errors, some are actual errors, but a lot of them are like, hey, I think this is wrong. Is it? Because sometimes we've intentionally done the thing that the tool doesn't like.
I have a contentious relationship with this kind of thought process because I've had to deal with it a lot in my other roles. And the reality of what you're talking about is this: the marketing department has to prove that they're doing a good job. Okay? This is a typical generic company. What they do for that is that they write articles, they do SEO and stuff like that. The next month comes along and they didn't increase as much as they wanted to do. Right? So now they're like, okay, well, why didn't we increase as much as we wanted to do? They look at their own content, they're like, this is fine. Then they go and look at the website and they're like, oh, the website's SEO value is low, the page speed is low, so the website's the problem, right? And that, to their departments, to their leads, they'll be like, the website's the problem. Obviously, the website's the problem. And the website is fixed to a certain degree. Same exact things repeats, and the same exact outcome comes in. Be like, oh, you guys improved the website, but it's still not perfect. So it's obviously still you. That's the problem. And so this cycle repeats until either the developers are fired or the marketing department is fired. I'm being blunt here, but this is a cycle that I've lived through like 2 or 3 times in different companies at this point. And the reality is that like, is it important for the site to be like fast? Sure. Is it important for all the SEO scores to be high? Sure. Is the content and the marketing and the advertisements and the Google ads, the Facebook stuff, Twitter ads, Reddit ads, is that more important than this stuff? It's not even in the same stratosphere. If you have a good content writing team, if you have a good marketing team that can do Google ads really well and Facebook ads, you're going to succeed regardless of the website. If your website's a piece of trash, you're still going to succeed. Yes, if the website improves, you might succeed a little bit more, but the failure isn't going to be the website. I can guarantee you that. The failure is almost always, and this is a biased take because I am a developer, almost always on the marketing side of things, unless the website is literally down, like not accessible. That's my rant for this topic because I've experienced it multiple times. So in this situation, in the situation that I say, I always go over heads. If it happens once, sure, like obviously you're going to fix it. But if it continues to happen, I'm going to whoever is above the marketing department, whoever is listening to their whatever in their ear, and I'm going to do the same thing that they're doing. We're having an internal war until one of us is gone.
Well, the thing that sucks too is like with a marketing war like that is what I always find is I go, okay, if you want this, then we're going to have to cut this out. One of the things that we had a problem with was pagination was showing up, like our paginated pages on a project was showing up under SEMrush. And, SEMrush is saying, hey, like these pages are like redundant. It's the same content. It's whatever. But I've explained a million times. I said, yes, like the SEO tool is giving us a warning, but Google themselves in this particular case literally said, like, we ignore for SEO penalty. We don't give a penalty out for paginated pages that are clearly labeled as, page 1, 2, 3 through 9 or whatever. We don't do that. And I've explained that to people, to like clients so many times, right? And they're usually more of the marketing arm because it's their business. And they'll be like, well, no, like SEMrush is saying this. So I said, okay, that's it. Then we can't have pagination. And we can only have, not even 100 articles on the page, because we need to have performance. So we need to have 10 articles on the site, and the rest of the articles are going to have to be accessible by search. And it's like, they won't give for that. Like, they're not going to give it all. They're going to be like, no, like, our articles need to be shown. There needs to be clear pagination. There needs to be whatever. And it's like, no, like, you're not understanding. Like, in order to fix the pagination quote unquote error, we have to get rid of pagination, because this is how our software handles pagination, and this is how we're going to handle pagination. You know what I mean? Like, especially if we're using a no-code tool or whatever, because again, I usually work with people with lesser budgets. I can't just go and, remake something or like have another tool. Like, it's going to be too many dev hours, or the tool we've chosen has a premium plugin that could change it and they can't afford it. So that's it. Like, it's over. Like, this is how pagination's done. So if you don't like it, we have to then change it. And you're right. Like, it becomes like that war, right? Where it's like, well, no, like, our marketing is doing great. We don't want to change anything on our side. Like, you just need to fix the site. It's like, yes, but you don't understand that, like, we're working on this together, where like you would need to change the pagination. Or a classic one I always try to do is, I'm like, hey, compress your images. And they go, well, then the images are compressed and they're not going to look as nice. And it's like, correct. But no one's sitting there looking at this like it's a Picasso. Like, you have to make it so that if you want a full res image, it's like a light box. Someone clicks it and then a full res image loads later. That's fine, because someone realizes, oh, I've clicked on this. It's taking a couple seconds to load because it's like a 4K nice image. Like, of course, right? Or they're clicking to download the image if it's like a wallpaper site or something. So of course they're okay with it taking, 5 to 10, 15, whatever seconds, depending on connection speed. But you're right. Like, it comes this war of like, oh, it's all the devs' fault because, like, they're just not doing all these changes that I told them to do. And it's me going, well, hang on, these SEO tools, a lot of this stuff it's objective. Like, my number one pet peeve, and I'm sure you've been here too, is I will go to a competitor and I will run it through the SEO tool. Because a lot of these SEO tools, you just run it on the public site and it reads the site and does whatever it does. And they'll have the same or more errors than us. And I'll be like, look, the person that you are trying to imitate, the person we are trying to, take out, for the lack of a better way to say it, the person we're trying to be, this like large company in our space, we're a startup, we're trying to take on this big company. The big company doesn't care. And then their answer is like, well, like, they don't need to care. It's like, well, hang on, but it's not holding them back, right? And then this is where exactly what you said, Mike, this is exactly where this starts going. And so, yeah, like, I mean, I didn't mean to derail our refactoring section, but this is like when you and I deal with clients on the web agency, this is our refactoring almost always. So it's always someone brings up an SEO tool or has some sort of random, sorry, but dumb request oftentimes. And then it becomes like, well, like, you just need to do it. And it's like, well, if I just do it, it's going to show up another error. And then they don't agree with that. And it's like a whole thing. It becomes a whole thing. But I'm going to end my rant there. I don't want to like completely derail your refactoring stage, but I guess there's refactoring and then there's refactoring for clients is almost two different sections of this episode.
Exactly. Like, refactoring and optimization are very close together. I would more put this towards optimization, because like optimization essentially is almost something that it is something that a client would ask for, like you're saying. And that's where like you're like, okay, as an optimization, what are going to do an optimization sprint? It's easier to justify, right? Like, because it's something that a client can maybe potentially see. Whereas refactoring is actually defined as like something a client won't be able to notice, or like the end product won't be changed because of a refactoring. It will be just easier to maintain said end product in the future. So the client doesn't really care a lot of times. This is where the nuance of you trying to figure out how to add refactoring into your process comes in. And, if you have a good team, if you have a good leadership, refactoring is part of the process. Everyone understands. But if you have a team that's like, we need to build, we don't care about anything else, then you're like, well, how do I refactor? You don't. And then your code becomes a disaster and a mess, no matter how many rules you put in place, and eventually becomes unmaintainable and you have to rebuild completely. So you have to sell it a lot. You have to, as a lead or even as an engineer, whatever, you have to sell it to the leadership and be like, hey, we need to, once a quarter, once a month, whatever the cadence you think, let's have a few days of refactoring. The whole team just goes in and fixes the stuff that they have to-dos on, which is like the meme in the dev space where like you put a to-do in your code and it's just there for for eternity, right? But if you have a refactoring week, right, every quarter, then those to-dos can be knocked down. Like, you can go through and refactor. And you can go through and identify areas where you can make your code more readable and more maintainable. So personally, I think refactoring should be part of the process. Again, it should be factored into the deadlines. It should be factored into the development process where your team knows that, hey, We're going to go back and refactor this. It's not just like a thing that people say, like you're actually going to go do it. And that's going to make your code better and more readable and move on. The other argument to this is like, no matter what you do, you might have to rebuild or rewrite. Even if you are perfect in refactoring, the first time you write something is probably going to be the shittiest time you write it. If you don't allow yourself to completely rewrite your application from scratch every once in a while, like every 5 years, you're probably putting yourself in a position where you're kind of limiting the potential of your application and the potential of, hiring better talent and stuff like that. I think that's a completely different argument or completely different episode that we could have even, but it is kind of relevant to the refactoring side of things because like you can be like, screw refactoring, we're going to rewrite anyway.
How far would you say you should be pushed before you do a rewrite? Because certainly there are times when it's like we're literally spending so much time bug fixing and like refactoring. It's like you kind of go in and you more or less spend all your refactor time reading through like a smorgasbord of like what is affecting what does this. Then you're like, I'm going to change this string to hello instead of hi. And then the whole code, the whole site goes down. And you're like, okay, so the whole site is built upon a hello. Like, that's not great.
Yeah. I don't have a good answer for this one. Like, I think it's very difficult to decide to do a rewrite because like what you said, it's like, it is a very drastic thing. Like, oh my God, like we're going to have to completely rewrite this. But I also don't think you should ever put it off the table. I think that that's something that you just need to have as a potential thing that you can do if the situation arises where you figured out that, hey, you've written this incorrectly. A new piece of technology comes out and is vetted and tested and all that does drastically change the way you can do things. Like you should allow yourself the ability to do a rewrite, but not have it as something that you just rely upon, which would, again, factor into the whole like, hey, let's make this code shitty anyway if we're going to rewrite it. Like, that shouldn't be part of the process. You should write your code like it's going to be maintained for 10 years because tomorrow you could move on to a different company. And then if your shitty code is back there, right? Like here's a real scenario. You wrote the shitty code, you move on to a different company, and then you're fired from that company and you need to go back to this company or you need to go to a different company and you're working with an engineer that worked with your shitty code that had to maintain it. Are they going to hire you?
It's a fair point. Yeah, it's a fair point.
Yeah, probably not. And the industry, yeah, there's a lot of us in there, but it's a pretty small industry once you get to near the top. People know about each other. So like the reality is that like, yeah, you should care about the quality of your code to a certain degree. And you should care about the legacy that you're leaving behind, even if you're going to leave the company. Because if you wrote great code, are they going to hire you in that situation? Hell yeah.
Right.
You're putting your reputation on the line a little bit. It's not a showstopper. Like, junior developers, don't be freaking out right now. Be like, oh shit, I wrote really shitty code and I moved on. It's not going to affect your life that much. Trust me. It's not that big a deal.
Well, people are also going to realize that you were a junior too.
Most likely, yes. You weren't the one making the decisions. It's different when you're a senior dev.
I mean, it's the same in a lot of different industries too, like server admins. Like if someone's just like really bad and then someone else comes in, it's like, oh my God, all the cable management's horrible, all this and that. And I'm sure this happens with a bunch of stuff, content writers too, right? Where, we hired this content writer and then, it was due to the content being bad that the traffic went down. And you're going to gain like a reputation in these spaces, especially as you niche up too, or niche down, I guess, because, if you're like starting to like zone in, you're like, I want to do Web3 stuff. Then you're only doing, websites and web apps. If you're a web developer for Web3 projects, then it's okay. Or like Webflow too. Like if you're in just the Webflow community and you're constantly, tweeting or whatever about Webflow or X posting, anyway, whatever about Webflow, then like you get a reputation of like, okay, this person, quote unquote codes or no codes, whatever, in Webflow like this, is that good, bad, whatever. And I've seen so many, it's like the meme of Webflow where people just leave like the classes, like if you go make a div and then you make a change to the styles, it'll just make a class called like div block and then a number. And like the whole website's done that. Like everyone has like certain, divs that have been quickly done that have the auto names for sure. I have it. Everyone has it. But when the whole site is that, and you're like, is this a title? Oh no, that's div block 182. It's like, what is div block? What is div block 182? Like, what does that mean? So it's a little bit of a disaster in that regard.
Yeah, absolutely. So that's what you want to kind of try to avoid as you progress in your career and get better and better at writing code. Is you don't want to be that guy that's just like, I don't really care about this quality of this code. I don't care about anyone reading this code. And I've met some developers like that. I've met some developers that are like, I could give a crap about next person that reads this code. And I just think that's a flawed way to do it. Yes, I get it. Sometimes you're just in a bad situation and like you get into a bad mood and whatever, like that and that's just who you are. And that's like, I've had those thoughts too, like, not gonna lie, like I'm not trying to like, grandstand or anything like that. But the reality is that your decision making now could affect you in the future, and it's just better to be better. I don't know.
Yeah, no, absolutely. And I have kind of like a final question. So with refactoring, like you're going in, you're cleaning things up, you're doing whatever. Okay, so let's say you're a junior dev and you're learning, and so you build your app this way, whether it's like literally for pay, like you built an app for somebody, you built a website for somebody, or you did it for like your first portfolio project. And then, just 3 months later, you might be way better, right? You might be way better at that certain concept that you did, like going through arrays and handling arrays or something like that. And so you're like, oh my God, like I looked like a fool back then. Should those people worry about going back per se? Because I know you and I have had this conversation on the show and off air where like, I'll be like, yo, Mike, like, is this code okay? Because I don't code all that much. And you'll be like, yeah, like it works. It's not crashing. Like you're good. Just use it. And I'm always thinking to myself, like, if I get better at this, like at whatever concept I'm doing at the time, array handling, conditional statements or something, if I get more efficient at this, short of it being like a major security flaw that I literally should go back and fix for somebody, or at least mention to them, how much time should people be sort of almost like, I guess, neurotic in a way where they keep going back to their old projects, especially in those early days of learning, and like constantly reiterating? Like, is that worth it? Because then your portfolio, instead of having 10 projects, is like 2. And you're like, well, I just kept getting better.
Okay, so that's very, very good to bring it back to the portfolio. If you're putting a project on your portfolio, yes, you should go back. If you are applying for a job today with the skills you have today, and you're putting a project on your portfolio with the skills you had yesterday, they're going to look at your skills yesterday and not hire you, like just bluntly. So it's better to have 2 or 3 good projects that demonstrate your skills today, rather than 10 projects with progression, like, crappy code on one project, decent code on another, because it shows inconsistency. Like, you want your 3 projects to conform, to be good, to have code standards, to use linting. You want to put effort into this. Like, it's a very competitive landscape out there. Like, it's tough. It's tough to get a job right now. So if you're waffling on a project that you don't like the code quality and you're trying to apply for a job, that probably tells you that you need to go back and fix it. Like, if it's not up to your own standards at this point in time, that's a good indicator that's probably not up to the recruiter standards or the hiring managers.
But there's also a line too, right? Because like with the portfolio, it totally makes sense, of course, because you're trying to showcase your best work. So if you've done 10 things, maybe you only show like 7 through 10. Maybe like that might be how it ends up. But like I've definitely gone back and fixed or enhanced or like added features to old projects that are like 5-7 years old that I've done. And they're not like, security ridden. It's like more like CSS inefficiencies where it's like, man, why the hell do I have so many wrappers? But at the same time, it's like, I'm not paid to go back and fix it. So you do have to have a little bit of like, do I go back and fix this? You know what I mean? Or do I just go like, well, it's not causing a security problem. The person likes it. And, the new code that I add to it will be better, I guess, right? Like I'm not going to go back and redo every website I've ever done to like 2024 standard. And then next year go back and redo everything to 2025 standard. Cause like, hopefully you're getting better year to year. There is like, if we take it out of the portfolio game, there is a little bit of that money game, agency game to consider as well.
The agency game is a completely different one. No, you wouldn't go back and fix your website that you did 10 years ago for free. Like, that doesn't make any sense. It's all about like who's going to see it, right? Like, if you're not promoting that website as the one that you're going to show to everyone when you're trying to get a new client, it doesn't matter. Like, is it working? The client's happy? Done. That's the checkbox that you hit off. So absolutely, it's super nuanced. This conversation is extremely nuanced. Don't go back and start redoing your project you did in grade 1. Like, it doesn't make any sense.
No.
If you're looking for a job, do 3, 4, whatever. Like, redo 3 or 4. Don't redo 10 because, you're going to age out of the industry essentially by 90 years old by the time you finish your 10th project.
And then, oh my God, this one project had a VAR, and then you're on your deathbed and it's over.
Yeah, exactly. So like, yeah, get into the hiring process as quickly as possible. But yeah, if you're talking about a project that no one's ever going to see or no one cares about anymore, yeah, definitely make a new one.
Yeah, and honestly, like I've absolutely seen that from people too, where we've gone to like replace someone's work just because it's aged out, and I'm like, man, like they have their like this has been designed by whatever company, and I'm like, holy crap, this is bad. Is this how they build everything? And I click on the link to go check out their agency, and it's like a whole new agency now. So it's like, oh, okay, this is an old project. It's an old way of doing it. You know, it's forgivable at that point. Whereas like if they're like, yeah, we still use WordPress 1.0, not okay. But people grow, people change. That's it. I think we've covered it, Mike. I don't know if you have anything else to add to this episode.
No, I don't. I think we've done a good job. Pat on the back right here. Pat on the back.
And I'm going to do it. But one of the things I friggin' hated in elementary school, everyone pat yourself on the back. I've never asked anyone to pat me on the back. So like, why am I patting myself on the back? You know what I mean? Like how many times have I been like, yo, man, like go to my girlfriend and be like, yo, man, just give me a quick pat on the back real quick.
I do appreciate getting them sometimes, though. I mean, it's usually ironic, but I'll take it, even in an ironic situation.
It's more of the symbolism.
Good job, bud.
Pat on the shoulder, please. Anyway, I'll take a pat on the shoulder or a shoulder grab. I'll take that better. Go back and refactor your pats on the back. Anyway, before we continue talking about refactoring, if you want to support episodes like this, we are on Patreon. That's refactor your pats on the back. That's patreon.com/HTML, all the things. Check out the tiers and give that a go. And many thanks to our $3 tier patrons, Tim from the Web Hacker on thewebhacker.com, Jason from Geek Life Radio via geekliferadio.com, and Garrett Segal, Level Up Financial Planning via www.levelupfinancialplanning.com, Joshua via Silvio.us, and Magnus from YesWeb via yesweb.se. And last but not least, we'd like to give a shout out to Michael LaRocca, a contributing author on HTML, allthethings.com. Michael is the author of Self-Taught, the X Generation blog at selftaughttxg.com. Feel free to leave a comment or a review on the platform you're listening to this on, and this outro will sign us off.
You've been listening to HTML All the Things Podcast. Web development, web design, and small business. We hope you've gotten some useful and practical information from this show. And we hope you appreciate that we talk to you like human beings. And we hope you had some fun. We'll be back soon. But in the meantime, hit us up on social media on Facebook, Instagram, and Patreon at HTML All the Things. And on Twitter at HTML Everything. Until next time, this is HTML All the Things, signing off.